one. It's called the range. All right, the range. Can you now? I'm not going to have you type in 5 darn numbers on your calculator in the list and then have it pop out the range when you can find it even quicker. All right, I don't know if you guys have heard range before, highest minus lowest. Okay, highest minus lowest. So range for this one. Highest is what? 98. And lowest is 68. So 98 minus 68. And give you 30. Okay, so there's my range for this. Let me start, instead of just finding these, let me start by just going over a scenario where these would be used. I'm guilty of it too, but a lot of teachers, I'm sure, they pass back the test or quizzes and it's like, oh, the class average was this. Honestly, for me, I don't care. It's more for you guys. What I care about is if I made a good test or not. All right, is the test good or not? And what do I determine if it's a good test? How close the scores are. All right, how close the scores are. If they're really all over the place, it probably wasn't a good test. Versus many of you scoring around the same amount or the same score, it's a pretty good test. And the way we can do this is what I'm going to show you today. I could find the range. All right. Problem with the range is, let's say all of you score around the same, and I got this one kid who's lazy and scored like a 56. That range isn't going to really tell me if I did a good test, if the scores are around each other. But that's how you find the range. Another way to find consistency on scores is the interquartile range. Where do 50% of the scores fall around? All right, 50% of the scores, that's the interquartile range. And it used to be you'd have to memorize this, that it's the third quartile minus the first, which is broken up into 4s, but your calculator does it now. Okay, so you don't even need to memorize that formula. So let's pretend I wasn't here yesterday. Where can I put these scores in so I can find all these different values I showed you yesterday? So I go to my NumWorks, but I wasn't here yesterday. Where do I go? I go to statistics, correct. I go to statistics, and then up will pop a list. And we type those numbers into that list. So be careful, again, be careful if you're typing them in, all right, because you guys go so fast. A 75 could easily become just a 7. And I would just go up again, press your up key and make sure everything's typed in correctly. You don't want one of these to be a single digit because that'll throw everything off. And there's no, because we're using the calculator so much, there's not going to be much partial credit on the quiz Thursday. Okay, so you want to make sure you type that in correctly. All right, going up now, go over to stats, right? We go over to stats. Execute, it gives you a bunch of values. All right, everyone see it even gives you the range, which we talked about earlier. Does give you the range if you can't subtract the highest minus lowest on yourself. But we're looking for the interquartile range, which for this one is 15. Real quickly here, it is awesome that our calculator does everything, right? If we use it correctly, but I do want you to know what the heck this all means. So what's that mean, that interquartile range of 15? Let's say, I don't know, let's say the average, the mean on a test was 84. If you add and subtract 15, that's where 50% of the scores would be. All right, so if you could see where you fell, if you fall inside the 50% or below or above, that's what the interquartile range is. Add 15, subtract 15, that's where 50% of the scores are. Okay, 50% of the scores are in between there. Is that something good for me to use to see if the test was good or not? Probably not, because anybody see a little outlier up here? Right? 51. Okay, so I probably don't want to look at, the bigger that number is, the more spread out my scores are. Right? The smaller the number is, the more consistent there. All right, so we have one final measure of how spread out they are, and this is the one we're going to keep using, and the best one, called standard deviation. Okay, standard deviation. I'll get back to your calculator in a second. All right. Actually, why don't we? Do you have it up right now? Still? Do you have the values up? I want to just make sure you guys notice something, that there's two types of standard deviation on your calculator. Okay, there's standard deviation, and then there's sample standard deviation. If it is not asked, we just use standard deviation. The only time I'll ask for sample is if I come out and say, find the sample standard deviation. Okay. Sometimes this is referred to as population standard deviation. Okay. So population standard deviation is right here. And then if I want sample, obviously you give me the sample. So there's two types. All right. Two types. Please put a note in your packet for me, please. All right. Under here, please put a note. The smaller the standard deviation, the more consistent the scores. Okay, that's something you need to remember going forward. The smaller that number is, that standard deviation, the more consistent it is. So if you look here at question number 1, I don't want you to calculate it. Just look at them. All right, just look at them. Which one's going to have the smaller standard deviation? If you look at those scores, which one's going to have the smaller one? The ones that are more consistent, which would be set B, right? All right, so set B because the scores are more consistent. Okay, so the smaller that number is, the more consistent your scores are. All right, bless you. Let's look at two families right now. The Miller and the Lopez. The Millers have 3 kids of those ages, and the Lopez have 4 with those ages. We're going to do this separately. First, for the Millers, can you guys calculate the mean and the standard deviation? Okay, the mean and the standard deviation. So go back to the calculator. I'm sure you could find the mean quicker, adding them up and dividing by 3, but standard deviation, I don't have a formula for. The calculator does it. So go back to data. You guys that were here yesterday, instead of deleting every single one, how can I just delete the whole thing? Shift back, right? Shift clear. Deletes everything once you confirm it. So all I'm going to do here, 10, 12, 14. 10, 12, 14 for the Miller kids. I go up. Stats. It'll give us the mean, which is 12. And then how about the standard deviation? I'll just abbreviate SD here. Standard deviation. About 1.6, we'll say. About 1.6. And go ahead, clear it back out and go ahead and do it for the Lopez family. We're getting the mean of 10 here. And standard deviation about 3.6, 3.7. Okay. So what can you tell me about their spread and their ages? I know you can just look at it and tell, but now I want you to focus on right here. Look at the standard deviation. What can you tell me about their ages? The Miller kids were what? More consistent. Closer in age. right? Because it's got the smaller see how this is working, the standard deviation. The lower it is, the closer everything is. All right, so this can tell me the Miller kids are closer in age. Just by looking at the standard deviation because it's lower. All right, now here comes the fun. We're going to combine yesterday into today. Before you touch that calculator, this is called a frequency table. Describe to me what it means. How many hundreds are there? 2. So hey, this is what it's looking like. Hey, and I don't need you to do this, but I need you to understand what this table is telling you. There's 2 100s, 3 95s. This is what it looks like if I listed out all these numbers. Okay, so that's what it means. There's not just 165, there's 9 of them. All right, 9 of them. So you guys are already going, so go. Because there's going to be some questions you can't answer here. Unfortunately, I'm sorry, your calculator won't answer for you. All right, we're going to have to actually do some math here. So take your time right now. I'm not going to put them in. I already have the answers. Because the first 3 questions are the only thing your calculator is going to give you. The other 3 we have to calculate ourselves. And it's so important to type these things in right, guys. So important. Because everything's going to get thrown off. So parts A, B, and C should be no problem. Your calculator gives you those values, and then I got to take over for D, E, and F. Wait till everyone's. I want everyone to try it on their own here. Find those values on your own, and then we'll compare as a class. Any issues with the calculator here? Go over stats when you're done, and all the stats will be right there for you. Okay, what's the interquartile range? If we type these in correctly, what do you got? 23 should be 23. Okay, mean to the nearest 10th. I have 79.5. If you're not getting these values, you typed in something wrong. I don't know what else to tell you. All right, I don't know what else to tell you. You typed in something wrong. Yes, Harper, I'm going to probably respond by saying the same thing I just did.
I got the same mean. I got 79.5, but for the range, I got 35.
Well, I'm not looking for the range, though.
It says
interquartile range is different than range. We went over it at the beginning of class today. Let's do it one more time. Range, highest minus lowest. Interquartile range is what your calculator is going to give you. You have to look at your calculator, please. Look at your calculator, please, so we don't have this argument over and over again. Go to your stats. Okay, you got 2 of them on there. Thank you. Please read carefully. And then we have population. Now look, it says population. We're looking for the standard deviation. If I want sample, I'll write the darn word sample in there. Okay, but population standard deviation is just the standard deviation on your calculator. Nearest 10th, 11.7. Okay, we ready? Because now we got to learn something. We just can't type in, look at our calculator. Question D, what is the number of scores that fall within 1 standard deviation of the mean? Let's first start here. What did we find out the mean was? So 79.5 is in the middle here. And I want to find how many scores fall within one standard deviation. What did you find was the standard deviation? 11.7. So I'm going to use that and the mean to find how many scores fall within. So 11.7 plus 79.5. What score do you get? 79.5 is the mean plus another 11.7, which was my standard deviation. You get about what? 91.2. So 91.2. And again, how did I get that? I added my standard deviation within one. So now I'm going to have to find what's one below it. So what do you think I'm going to do with the standard deviation now? Darn right, subtract it. So now I subtract 11.7. And I end up with a score of 67.8. So anything between 67.8 and 91.2 is considered within one, in between. And everyone see how I calculated those scores? I added and subtracted your standard deviation. That's within one. Our job's not done yet. Now I got to hit up the table and figure out how many scores fall between 67.8 and 91.2. So let's go to the table. 100 going to count. So let's go down from the bottom. 65 counting. Nope. And you don't need to do this. I'm just crossing them out up here. Would 74 count? 79. 85. 85 count? 88. 94. Nope, but we don't have to go above. Okay. If your answer is 4 scores, you haven't been listening to me. The answer is not 4 of them. Because how many 74s are there? 3 of them. So I need to add up how many times each occurred. And that's how many scores there are. There's not 4 scores. All right. I need to add up how many times they occurred on the frequency. So the actual answer to this question is going to be what? 7 and 8? 15 scores? 15 scores fall within one standard deviation of the mean. Within one means in between, above and below. Above and below. So I add it and subtract the standard deviation to find it. Ask anything here. All right, next one. Oh, I know you're fired up to see that word again. What's the probability? I pick a score that falls within one. All right, probability, answer's got to be a fraction less than 1. Right, got to be a fraction less than 1. So might as well just start right there. What's the probability I pick a score that will fall with, well, we already found how many scores fall within 1. We already did the hard work. So 15 out of the total. And there's 2 ways you could get the total here. You could add them up yourself, how many scores, or go back to your calculator. Go back to your calculator. And it does everything for you. Remember, I don't have the scores you have in here, so I have a different number, but look at the first one. Number of data points. It'll tell you how many you plugged in. I know mine says 3 because I'm still on the Miller kids. But what yours would say what? 30. Yours should say 30. So that's how many, that your calculator will also tell you how many values you're plugging in. All right? Ridiculous. But I'll take it. So 15 out of 30. Questions? All right, let's see if you can figure out this last one without me saying much. What percent of scores fall more than 1 standard deviation above the mean? How many scores? What percent of scores fall more than 1? So I'm not talking within anymore. More than 1 above the mean. So you tell me, what scores am I looking for? Anything that is 91.2 or above. Okay? Above the mean. More than 1 above the mean. So I'm looking for anything above 91.2. So you guys go to the table. How many scores are above 91.2? What do we got there? 6? All right, but I'm looking for, 6 isn't going to cut it because that tells me in the problem you said 6%. All right, 6 out of 30 but I'm looking for a percent here. So I have 6 out of 30, right? I go back to my calculator. If you want to go home, calculations, right? 6 out of 30. And that gives me 0.2, right? But I want it as a percent. So multiply by 100 like usual, 20%. I need you to call me over if you get confused on those questions. All right, call me over here because you need to be able to do this to understand tomorrow's notes. All right, and I know you can just get every value off the calculator except for these questions. All right, so go ahead, let's roll.